Yo, what is up, guys? Welcome back to another episode. GMAK, the Boiler Men, you know what it is. Man, we just eclipsed 700 subscribers. On one hand, couldn't be more grateful. Appreciate the out of all you guys. Anybody that has come to the channel, been involved with the channel, commented on the videos, liked the videos, we couldn't be more appreciative. This channel wouldn't be where it is without you. While you're at it, man, subscribe to the channel if you haven't, and smash the like button as well. It really helps us and the algorithm. On the other hand, I feel like it's been a little bit slow, and it can be frustrating at times, and that's the social media game. But it doesn't mean we're going to stop anytime soon. If anything, we're just going to ramp it up a little bit more. We really want to bring you the best content we can. We like to talk about boilers and everything boiler related. We do get into some of the trade stuff, but it's mostly a boiler related channel. We're going to talk about different things, including what we're going to talk about on this topic. And on this segment, I kind of wanted to get into some of the wiring stuff, and I'm not going to get into the weeds on circuitry and things like that, but I really wanted to get into what I call the limit circuit, or I don't know what some people call it. Like in our industry, I have the control circuit, which is basically my power circuit for the burner, and then I have the limit circuit, which is basically all the safeties that are daisy chained together, and that's what really makes the operation of the system what it is. And I wanted to get into it because there have been some things that have been brought to my attention over the past few months while we've really been in the depths of winter and dealing with some electrical issues, some system issues as it pertains to this particular topic. So it's something I really wanted to get into because it is hard for someone like me who has been in the business for so long, and I do a fairly regular basis try to remind myself that there was a time when I first started in the business and I really didn't have a lot of knowledge. So when you're explaining, teaching, passing on knowledge, you have to be mindful of the fact that the people that you're teaching it to don't have the knowledge that you have. So there's a language that we use, there is a way of teaching, and you have to be flexible on who you're talking to, how it's being perceived, each person's attention span, how they receive information. So I've talked about that on previous videos, like the ability to communicate the thing that you're trying to communicate, especially as it pertains to safeties and the boiler operation. But in this particular scenario, there was a couple of times over the past few months that I've had guys that with a little less experience that have been on job. And I only bring this to your attention, by no means am I throwing these guys under the bus or anything. I couldn't be more proud of our team. This was one of the most wicked winters that I can remember in my recent history, even going back into the 90s when I was a kid. I wasn't even in the business. Between the snow and the temperatures and all the craziness, this is definitely the busiest and most out of control winter that I can remember. So I had to put certain guys that weren't particularly in certain scenarios during the calmer months in scenarios that they probably wouldn't have found themselves in otherwise had the weather not been so chaotic. And through that, I understood that I had to try to find a better, more economical, or maybe not economical, but it's like drawing between the line between a straight line between 2 points is the fastest way, and trying to find the route to get to the information that is needed by my guys out in the field as clearly and as distinct as I could possibly make it. And it always came down to these wiring issues, safeties shutting off. And I'm not talking about jumping safeties or issues with safeties. I just mean, as an example, right? We have two separate circuits that I'm talking about in this particular video. I have my main circuit, control circuit as I call it, which comes directly from the breaker panel in the boiler room, travels up, and so in New York City, they want us to go through the manual reset pressure control on a steam system, and then from there down to my control power for the burner directly, so one straight loop. So if my pressure exceeds my operating pressure control and then goes to my manual reset pressure control, that kills the power in the entire burner. Now, included onto that, sometimes we will put the manual reset probe type low water cutoff, which is also required by New York City DOB. So in New York City DOB, just to be clear, I'm required to have 2 low water cutoffs on my industrial boilers. One would be a float type or a mechanical. So like McDonnell Miller makes a 67 and 63. They make a whole bunch of different ones. That would be my main low water cutoff. So that's a float type. So where the float attaches to the arm. So if the water level goes low, shuts the power to the circuit. And then I have my manual reset probe type. They want it manual reset, so if the water does go that low, you physically have to go to the boiler room to turn it back on to figure out where the issue is. But so sometimes, with all that being said, sometimes that manual reset probe type low water cutoff could be tied into that same circuit. So if the water goes below my mechanical low water cutoff and goes to my probe type, it also kills power to the burner. Because one of the things we definitely don't want is too high steam pressure, and we definitely don't want to be operating the boiler with not enough water in it, right? So those are the 2 main things. So like I said, goes from my breaker panel, 15 amp breaker, doesn't have to be anything crazy. There's not a lot of amperage on that circuit. Goes to my manual reset pressure control. Could go to my probe type low water cutoff for power, not for limits, power. And then down to, on most of these burners for us, could be like number 1 on the terminal strip, but in this purpose it's just the power portion of turning on the system, and that's its own circuit on its own. So those 2 items, for whatever reason, shut the power, shut the circuit off, or I get too much pressure, I have not enough water, it kills power 100% to the burner. There's no relay on, there's no power going to it anymore. And again, these are just safety precautions. Now on the flip side, we have what I call the limit circuit. I don't know if the language is the same in different places. I assume it would be, but for us, we've always called it the limit circuit. That's going to be my safety loop. And that safety loop is always daisy chain, right? So like I explain to my guys all the time through the years, and for whatever reason, I guess this is just like the thing that I realize makes the mind click for certain people in the field. Because it's not that it's complicated, it's just like when you first start and you're trying to like take in all the you're learning systems and how things work and different controls and to explain how the wiring or electrical portion of it can be a little bit difficult for new people. So I always take my guys' hands, like I'm not holding hands with the guys in the boiler room, but I explain it to them. It's like as if you had a circle of guys or whatever, girls, doesn't matter, holding hands, and then one person lets go, the daisy chain stops. Limit wiring is exactly the same way. It's literally one to the next to the next. So if any one of those items, the circuit opens, right? So let's talk about circuitry. When we talk about wiring, we talk about closed and open contacts. So in the situation where I want the boiler to run, I got to make sure that all of those circuits along the way. So I have, as an example, I have my mechanical low water cutoff. I have sometimes a smoke alarm, right? When I have dual fuel burners, and ones that run on oil, I have to have a smoke alarm as per New York City DOB. So the smoke alarm will also have a limit circuit in it. We have spill switches, so if the chimney blocks up and we get heat transfer back through the draft regulator, that's another one in the circuit. We have an operating pressure control for the steam system in certain cases. On a hydronic system, it might just be the aquastat, or it'll be the aquastat. You'll have rollout switches. You'll still have a spill switch, regardless. So, and then off of that, we would have, sometimes it's the high and low gas pressure switch. Depends on the burner, and everybody wires things slightly differently because there are other circuits. But as it pertains to my safety circuit, those things would be daisy chained together. So if my stack temperature gets crazy and the chimney's blocked up and the heat pushes back into the boiler room, that spill switch is going to feel that heat, trip, shut power off to that limit. And when that limit circuit is broken, or the circuit is open as we call it, then the burner will not fire. Low water cutoff, no different. It's in that same daisy chain. So imagine one big circle of wiring, closed loop circle, boom, the low water cutoff trips because the water's low in the boiler. That opens. Now my circuit is broken again. You can go as far as talking about the aquastat to the heat timer or whatever temperature control you're using on your particular building. For us, we use a lot of energy management systems. We have EMS systems like an NTEC in New York and probably some other places in the Northeast. And then heat timer also come out with a panel that would be in the limit circuit, but it's also in the parallel to my aquastat. So if I need hot water in the summer and the aquastat's calling, then it calls. And then in the winter, it works between the two circuits. So if I only need heat, heat will still call. And if I only need hot water will still call. And it still completes the daisy chain. So I'm not trying to confuse you. And I'm not going to get into parallel compared to series wiring. But I'm calling it daisy chain just so you guys can understand it a little bit better. But for us, we call it series wiring. So it's in series with each other, one to the next to the next. And then once that loop is closed again, meaning the electrical circuit is closed, sends power back to my burner and goes, okay, I'm ready to fire. Now, why did I say all this? Why did I explain all this? Well, first of all, it's good education to talk about. It's important to have these base knowledge of how a system operates. There is a process of operation that goes on when the system calls for heat or hot water or whatever. Right, and then there's the operation of the burner itself. Now, I've done videos on that, so I'm not going to get into that on this one. But I wanted to talk to you about these things because I found guys getting stuck. And there are very clear indications of what's going on 90% of the time. And why do I say 90? Because if I was to look at a relay and diagnose what's going on, sometimes the relay can present itself as an open limit, which technically in certain cases it is, right? If I have, like on a FireEye relay, it might say L1 to 13. That's my limit circuit on that particular relay. So if it says L1 to 13 open, right? Or on a Honeywell 7800 series, it'll say standby, even though I know my heating, my EMS system or my heat timer or whatever is calling, but I'm not getting it back to the relay. The relay saying, I don't know, I don't have limits, so I can't run, right? It's a safety precaution. It's there for a reason. So why I said 90 compared to 100 is that 10% of the time you can have electrical issues. We had that a few times this winter. Guys got stuck. Turned out to be shorts in, the tubing or whatever. You got to remember, man, this is New York City. We get floods. We get different things. So there's, and then there are a lot of guys, like I never understood this, but on our jobs, a lot of times you're going to have where the EMT for the wiring was like run underground. So it might come from, like, let's just say the breaker panel or my electrical panel where all my main electrical is 20 feet from the burner. They used to run tubing underground, cement everything over it. The problem with that is over time and soil and floods and water and exposure, water builds up inside there, could rot out the EMT. And then in other cases when we have floods, water goes into the tubing, is now sitting in there with the wiring, and it can mess up the wiring over time. So we get electrical shorts. The problem is, I've tried my hardest to explain, it's not rocket science at the end of the day. Yes, I am a seasoned guy in the business, but still, when you understand that all you're doing is running one circular wiring, one pattern of going this thing, this thing, this thing, this thing, I can't begin to tell you how many times I had to get on the phone and say, okay, check this thing, check this. Like, it's the same thing every time you go to the job. It never changes how I'm going to diagnose that particular problem. Again, I'm not talking about everything. We're talking about limit circuit and control circuit wiring. So it's very clear to me when a guy calls me on the phone, he goes, this is what the relay says, this is what's happening, this is what my control board is saying. Okay, then I say, okay, well, you got to check your limits, and the limits never change either. Again, yes, there are times when somebody else wires a boiler to operate a little bit different, or how it's going to present itself as far as the relay is concerned. But again, I'm not going to get into the weeds on all that. There's just so many videos and topics we can talk about. But when it comes to limit circuit, it's literally a very simple circle of circuits, circle, square. It doesn't make a difference. Don't get all caught up in the shapes that I'm talking about. It's the point is, we're going around in a circle. It starts here and ends back kind of where it started. Yes, it's two different terminals, but it's like, okay, I have to send it out. Okay, I'm coming back. Burner runs. If I send it out and it doesn't come back, the relay will tell you, yo, it didn't come back yet. You say I'm sending, like I could test power going out. Oh, I got it going out, but I don't got it coming back. So what do I got to do? I want you to think about it. What do I gotta do? I gotta trace it in reverse. You could trace it forward, you could trace it in reverse. What do I mean? Most of our burners, it might be number 3 and number 4 would be my limits or my safety circuit or whatever the you want to call it. Doesn't matter. If I start where I have power and I follow that wire, now I know where my limits are because I know each control. But let's just say you want to dumb it really down. I'd say, okay, well, go to the place you have power and start following it. And you're just chasing the power. Where does it stop? And there's your answer. Again, in that 10% where you have electrical problems, that can be a little bit more convoluted, can be a little bit more difficult. And obviously in those scenarios, you'd have to go a little bit deeper diving, or maybe in certain situations like we've had, I got to call in more senior guys or myself to go down and kind of figure out where the electrical short or issue may be. But in general, that's all you're looking for. It's very simple. It's not overly exciting, honestly, but you know, the burners we work on and boilers we work on are pretty big, so it can involve climbing. Now, that's another part of it that I teach my guys all the time. Low-hanging fruit, man. It's like, my God, it's so funny now at this stage of the game when I go on the job, my guys are like, man, I checked it, low-hanging fruit, because I have beat this into their head. Why would I climb on top of the boiler when it's possible that the problem is me standing on the ground? Meaning, because like my low water cutoff's usually at standing height, unless I'm working on a really big boiler, then I got to get on a ladder. But typically on these jobs, the low water cutoff's at standing height. I can test power right there without having to get a ladder, climb on top of the boiler, be on top of the burner, whatever the case may be. So I'm going to check all my lower positions first. I'm going to check my high and low gas pressure switch. I'm going to check my lower the cutoff. I'm going to check anything that is within my sight or within my height. Now, I'm not tall, but I am tall enough to reach certain things. Now, if it power I have here, then yes, then I have to go to the next thing. And then in the case of like a spill switch, which is on my draft regulator, on some of our jobs could be 20 feet in the air, so then you got to dig for the ladder, right? Not all the time do we have the ladder. We don't typically carry them. We mainly like to have the customers have the ladders in the boiler room. Makes our life a lot easier. But my point is, at the end of the day, it's literally just taking the time to understand what you're looking at, what's there in front of you, what limits or safeties or whatever are involved in this particular job, because every job is a little bit different. Typically on these steam buildings, it's more or less the same. They might use a different type of control, but it's usually about the same thing, and you're just repetition, right? Everything is repetition. So I understand a guy who goes and hasn't had a lot of experience, but after the 4th, 5th, 6th, 7th time, I shouldn't have to say, yo, look at my limits. I want you to call me and be like, listen, the relay says L1 to 13 open. It's showing me open limit. I put the control on manual or whatever to run. Nothing's happening. I check this, and this. I can't figure out where my limits stop. Then we can have a deeper conversation. But typically, 90% of the time, you should be able to daisy chain it. One, boom. So like if it stops at my pressure control and it's not going through, but I have zero pressure, maybe the pressure control is bad, right? Sometimes the low water cutoff hangs up. We rely on the supers to flush them, right? Because I can't be at the job once a week or whatever, however many times you're flushing, especially in the wintertime, you're flushing it often just to keep the mud building up. Sometimes they hang up, so could just be that, right? So there's always a cause and effect. That's another thing I teach these guys. Everything has a reason. Everything is done a certain way for a reason, and there's always an answer, right? Always an answer. One way or another, there's an answer, and I think that's what separates really good techs from guys that are a little less seasoned and need a little bit more time in the pressure cooker, as I say it. But as time evolves, you start to understand that there's so much repetition to this. Every job's a little different for sure. You know, some of the wires are old wires, some of the wires are new wires. There's so many things to take into account, but on average, the job's going to look very similar. The response is going to be similar, and the way you test these things is going to be similar. So keep that in mind. I hope you guys got something from this video. Again, I try to do things that are not super complicated, because I understand also that a lot of people that may watch our channel are not super deep in the weeds on, you know, all the technicalities of this thing. I like to talk about things that are a little bit more surface level, because I think they're really important, and I think you can learn a lot from just talking about this. And I also leave my comment section open for you guys to create a debate so we can go back and forth and have the conversation. At the end of the day, you guys have heard me say this a million times. I have zero ego about me. I'm just looking to grow. There are always things that I don't know. I'm okay with that. I'm not like somebody that thinks I have all the answers by no stretch of the imagination. So if you feel you have something to add, or you're questioning something I'm saying, drop a comment below. Let's talk about it. I'm good with it. I don't care. I like those conversations, and that's what keeps the channel going, and that's what keeps everybody involved. I want you guys involved. I want you to be a part of this growth. I want you to be a part of this community. I do appreciate the hell out of all of you. Like I said, if you've been here for a while, we appreciate you. If you are new and you've watched this far and you didn't already, please subscribe to the channel. We do videos like this all the time. This is what we're all about. We're just trying to educate, talk, learn, grow, and just talk about grassroots. You know what I mean? There's nothing special here, no special effects. It's just me. I'm in my office talking to you guys, and I love talking about these things. The boiler business is something I've come to love and be passionate about. So I appreciate the hell out of you guys. If you guys have any comments, questions, concerns, drop them in the comment section, man. Like I said, let's talk about it. I do appreciate the out of you guys. Smash that like button while you're at it, and I hope you guys keep having an amazing day. Keep crushing in your business. Have an amazing one. Peace.